Hello everyone, I welcome you all to our channel once again. And today is the lecture 4 of relations and functions. And today we're gonna see some special types of functions. So let's get started. So the very first type of function we're going to deal with is greatest integer functions, also known as GIF, and represented by square brackets. Okay, so what is this function? If I tell you, then its graph somehow what looks like this. At point 0, its value is 0. Until 1, its value is 0. Then after 1, its value raises with 1. Until 2, it becomes same. So, if I want to write, I can write it as f of x is equals to minus 1, 0, 1 for x equals to 0. For x, so this point will be included and this will be excluded. This and this I'll write minus 1 will be from 0 to minus 1. Okay, so this is greatest integer function. Means it takes integer, only the integer part of the function. For example, if I say greatest integer of 5.1, so it will be 5 because 5.1 can be written as 5.0 plus 0.1. So this is the integer part, and this is what? This is the fractional part. This is the fractional part of the number or digit, whatever. Okay. Now let's take one more example. Minus 5.1. Okay. You just think of it. I'll get back to this question once we have completed the fractional part function. Let's get back to the fractional part function. What is a fractional part function? So we can say that every integer or every value or every digit, every number consists of its its integral part plus its fractional part. Okay, can we say this? Yes, we can say this. That every number consists of its greatest integer part and fractional part. Okay. Now, one thing to focus and one thing to notice that this is represented at this, right? And it's always positive. This is always positive. This can never be negative. You can see in the graph also. It's never below the x-axis. It's always above the x-axis. And it's between 0 to 1. Okay. So fractional part of x is always between 0 and 1. Sorry, these two x. It will never take a value 0 and it will never take a value 1 also. Okay. So now let's get back to a question. This. We can break it, break it like this. Yes, yes, we can break it like this. So we can break it like minus 5.0 and minus 0.1, or else we can write minus 6 plus 0.9, which is correct, which is correct. As I already told you that fractional part is always positive, so it can never be minus to 0.1. It will always be 0.9. because this is positive. So what do we infer? That in order in order to write greatest integer part of a negative number, we'll take a plus one value of it. Okay, what I means to say is, if we have to write greatest integer part of something like minus x, so what will it be? It will be minus of x plus 1. Okay, so this will be its greatest integer part, given x is the positive integer, right? And what if we have to write it as this? Then we can directly write it, whatever it will be. The Okay, cool. This thing, right? Now, there is a one more type of function, or else we can just get back to properties of fractional function, or properties of greatest integer function. So, after seeing the graph, what properties do come in our mind of greatest integer function? If you see clearly, then we can surely say we can surely say that the greatest integer of any number, like suppose a number is here, it always lie between this and this. Okay, it will always lie between this and this. So this will always lie between x and x minus 1. Yes, the greatest integer of any number x will always lie between x minus 1 and x itself. Chill. Okay. So we can write the first property. What is it? Greatest integer will always lie between x minus 1 to x. The next property, the next property is, what if I write it as this? Greatest integer, greatest integer, greatest integer of x. X can be any number, right? X can be any number. So for instance, we can take, let's take 5.1 plus 2. What will it be? We can clearly break it as greatest integer of 5.1 plus greatest integer of 2. What will be the greatest integer of 2? It will be 2 itself. What is this? This is 5. So the final answer will be 7. So can I write it as greatest integer of 5.1 plus 2 directly? Because greatest integer of any integer, it's always the same number, right? So I can write it as this. Yes. So this is the second property. Next property. Next property is actually very much interesting, right? Greatest integer of x plus greatest integer of minus x. What can it? What can it? As I've already told you that greatest integer of any negative part can be written as this, can be written as this. Yes. So we can directly write its value. We can write it as this minus this minus this. What will it be? Minus 1. Only and only if x does not belongs to integer. Only and only if x does not belongs to integer. What if x belongs to an integer? In that case, in that case, the greatest integer part function will be of no use and will directly be written as this. Hence, the answer will be 0. Okay. So these are the three main properties of greatest integer function. Okay. Moving on. Moving on to properties of a fractional part function. Fractional part function. The very first property can be that fractional part of any integer, any number, will always lie between 0 and 1. It cannot be greater than 1 and cannot be smaller than 0. It's never negative. What can I say about this thing? What can I say about this thing? And also, what can I say about the fractional part of an integer? It will always be a 0 because an integer will never contain a fractional part, right? So, can I write it as this plus this? And hence the answer will be this. Yes, because this thing is 0. Yes, correct. Now, third property. This plus negative of x. What will it be? What if I ask you, suppose, take this example only. Okay, we can take like 4.2, yes, plus minus of 4.2. What can it be? It will be directly 0.2. And what will it be? It will be plus 0.8. Yes, because this can be broken into minus 5 plus 0.8. Because this part can never be negative. It will always be a positive 1. So the final answer will be 1. So the final answer will be 1. But what if x is integer? Final answer will be 0 because it will be of no practical use if x is integer, and here x is not an integer. Cool. So these are the some properties and some common functions that we have in our syllabus. There's one more type of function called signum function. Signum function is very easy because it's nothing but piecewise function. We can just write it as its value will be 1, 0, and minus 1. Value will be 1 for every x equals greater than 0. Value will be 0 for every x equal to 0. And for every negative integer, value will be minus 1. It is very much easy. Also, it is represented as y equals to s, y is equals to sgn of x. Okay, so this is the representation of signum function. Graph is like this: 0 its value is 0, positive its value is 1, and negative its value is minus 1. Okay, y equals to 1, y equals to minus 1. So these are some common functions in our syllabus. We'll get back to you with some more interesting topics in the lecture number 5 video. Till then, goodbye and keep learning.